through this a bit quicker. So yeah, this is the concrete Cement Concrete Aggregates Australia webpage and Cement Australia webpage. Yeah, actually, anybody, difference between concrete and cement? It's another one of those things you see on those renovation programs where they mix up the terminology a bit. Anybody know the difference between concrete and cement?
Isn't cement just like powder that goes into?
Bang on. Yep, that's it. Yeah, cement is the stuff that holds concrete together. The concrete is that finished product. So that's a concrete column. It's not a cement column. It's got cement in it.
Cement's the stuff that you put in the mixer and you put like the dry lime and stuff like water and all this.
Yep. Yep. Yeah. Yep. So, but you know, yeah, you hear that a lot. Like people say a cement path or something like that. So cement is the actual the binding agent that goes into concrete. But yeah, the ingredients of concrete are your what's called Portland cement, or it's also called GP cement, general purpose cement. And you get your coarse aggregate. So your coarse aggregate is all your gravel that goes in there, and then your fine aggregate, which is all the sand. You need that mix of coarse aggregate and fine aggregate to fill all the gaps, essentially. If you only have coarse aggregate, then you get what's called a really bony mix, which is you get air pockets in there. You don't get the material filling in between those coarse aggregate. Then you add water to that, so your cement powder, fine aggregate, coarse aggregate, and water. And then to get the concrete to behave how you want to behave, you might add mixtures as well. So typical admixtures are slag from the production of iron, so the refinement of iron ore that produces slag. That slag gets crushed up really fine and added to concrete. What that does is it helps retard, that helps slow down the mix, the concrete going off. It also makes it a little bit more malleable and workable, and also makes it much cheaper and much more energy efficient, to produce a lower embodied energy. Because cement powder uses a lot of energy, or requires a lot of energy to produce. Whereas that slag, that's a byproduct of other industries. So that gets crushed up and it behaves a bit like cement. Well, it can be used as an additive to cement to a certain extent. But if you're doing, let's say you're doing a burnished concrete floor, like that's where you have a really nice smooth steel trail, like Bunnings floor. And yeah, anybody taking notice of floors in Bunnings warehouses? Yeah, really smooth, dark, grey floor, concrete. So that's done with just general purpose cement. You don't want any slag in that. Because if you use a cement powder that has slag or fly ash in it, it gives it a greenish tinge to it, and it doesn't darken up nicely. So this concrete out here, I think that might have been with slag or fly ash in it. Oh, what's that noise? No? What's that? Yeah. There we go. Cool. Bit self-conscious. Handy that. So typically you want to have that slag or that fly ash in there to slow down the reaction, make things easier for the concreters, enable your concrete to travel further, etc. Make it more workable and environmentally friendly, because there's less electricity that goes into producing that cement powder. Other admixtures you might want wetting agents to enable water to penetrate in there and use less water. Or you might so fly ash, things like that can be retarders, so they retard that process. Or sometimes you want accelerators in your concrete. You want things to make that concrete go off quicker. if you're pouring a concrete slab in wintertime, you want to have accelerators in that, because you'll start pouring it, and because it's so cold, it's not going off really quickly, and your concreters will want to still knock off at 3 o'clock. So they'll want accelerators in there, but if you're pouring in summertime, then you want retarders in it. Or if you want various different colours and finishes, then you want to choose your admixers for that as well. Probably the best, if ever you're going to be working with something specific, like to create a specific result, the best people to speak to are your concrete suppliers. So we've got probably either Hallett's or Direct Mix, really. Or Boral, yeah, in Adelaide as well. What's that? Premix, yeah. Yeah. So speak to them about what you're wanting to achieve.
A lot of people these days, they put a layer of epoxy, whatever it's called, just to give it that smooth shine.
Yes, yeah, on top after it's cut back. Down. Yes, yeah.
That's cool.
Yeah, it gives it a nice sheen and protection to it.
That's awesome.
Covered those fairly well. What we can, although one thing I haven't shown you yet is wherever you've got re-entrant corners, like here, like this, you need reinforcing going across those corners as well, because that's where you get cracking typically happening in a slab. So this is a bit of trench mesh, which is across. You can use trench mesh, or you can use crack bars in there as well, which are just reinforcing bars set at a diagonal across your re-entrant corners. You saw with our concrete slab details, with our raft slab details earlier on, that there's a high floor and then there's a set down. That set down is for this brickwork. So the brickwork sits within that set down. Typically you have a 76mm set down, which is the height of a brick. Then you have a cavity between the brickwork, and then you have the wall framing in there. With that set down, that enables flashing from your wall framing to be carried into your brickwork like this, to ensure that any moisture that comes down here goes out your brickwork and not back into your wall frame. So cement is not just used in concrete, but also in fibre cement sheeting. So it would be with your research task number 1, that's another cladding option we're looking at. We're looking at brickwork and compressed fibre cement sheeting. With all the issues around aluminium sandwich panel cladding, so combustible claddings, fibre cement sheet cladding has taken off a little bit more, and you see that used a lot more commercially, but also in some of the express jointed systems like this in the higher end residential builds, but also for some of your cheaper builds, fibre cement sheet weatherboards, etc., get used as well. So that compressed fibre cement sheet is a composite material made of sand, cement, cellulose fibres, and other additives to get it to behave the way you want it to behave. So it has those cellulose fibres in there to work as a reinforcing to bind it together. So it can be used for weatherboards, external cladding, commercial facades. Also internal linings for wet areas, you want to use a compressed fibre cement sheet or moisture-proof plasterboard, or for flooring under a wet area as well. Cement is also used in Hebel production. Has anybody ever seen Hebel? But Nathan, you probably would.
I've probably seen it, I don't know what it's called.
Yeah. So that it's actually what I'll do. What's that? Yeah.
Next door you have a block.
Yes, I was going to grab. Yeah. All right. I'll just pause that and I'll grab the block. Start it again. So that Hebel is concrete with air in it, and the way way that happens is that with that cement and aggregate mix, so it's a cement and fine aggregate to produce the Hebel, then an aluminium oxide is added to that, which makes the whole mixture foam up. As it foams up, it gets baked and dried, and then cut into blocks. So it's a bit like a concrete version of the aero bar or so, if anybody remembers those.
Oh, the chocolate bar.
Yeah, chocolate bars. Yeah. That'll be the last time a concrete sample is brought into class if that happens. Yeah. So because essentially Hebel is concrete, it has the same fire resistance properties. It's also very very strong in compression. You notice that. Actually, that's something I haven't really mentioned much of yet in this whole discussion around concrete, is that concrete is really good in compression, but not good in tension. If we get a piece of concrete and pull it, we can actually pull it apart. It takes a fair bit of strength, but it's not very good in tension, whereas steel is really good in tension. We can't really pull steel apart and stretch steel very easily. So the mix of concrete and steel together produces a very strong element, because we've got the compression from the concrete and the resistance of tensile forces from the steel. So with that Hebel sample that I passed around there, you'll notice there's steel fibres in that. That gives it a lot of strength. If that Hebel didn't have those steel fibres in there, then you wouldn't be able to use it as a flooring system to span between supports a long distance away. And also in that concrete core sample, there's steel bars going through that as well. So because Hebel is essentially concrete with air in it, it's fire resistant and resists a lot of compressive forces. But because of that air trapped inside, it also has a far better insulative value. So concrete, as a block, actually transmits a fair bit of heat. So heat transmits through concrete fairly well. It doesn't provide much insulation. But when you add air to it, it slows down that transmission of heat across. Also, because of the density of concrete, you get sound travelling through concrete relatively well. Like certainly, your sound attenuation of a concrete floor is much better than a lightweight framed floor. But when you add air into that concrete to make Hebel, it helps absorb some of that sound once again, because it's not a solid material. And then because we're adding a lot of air to this, so using a lot less cement powder per volume, it ends up becoming a far more environmentally friendly material because there's less embodied energy in it. And obviously much lighter to use on site. So if these were solid concrete panels, it would be very difficult to manhandle those into place. But being Hebel, you can lift them in and screw them in place. Yes.
How do they make it just like liquid?
No, so with that, so it gets mixed up, and then aluminium oxide gets added, which reacts with the cement powder and forms a gas, and it foams up, just like I don't know, like making a souffle or something like that. It expands, and then it gets baked, and it goes solid. So I think it foams up and goes solid, and then gets cut, and then they bake it in an autoclave. I think that's the process. But there's cutting, baking, and expanding in the mix. Yeah, exactly. Yeah. Oh, well, I think there's a lot of analogies between baking and concreting. There's,
I picked up a few.
Yeah. Yeah. So that Hebel can be used for external walling, or for flooring as well, for suspended floors. With your 150 mil thick Hebel panels, you can span close to 6 meters with one of those. So you can get that's quite a depth of Hebel. But that's a very impressive span to get, span of a material to that sort of length. So, yeah. Another use of concrete, we'll be looking at this a little bit more in projects 2 and 3, is tilt-up panel construction. So, used not only in concrete footings but also in walling situations. Yeah, something you don't see. What's that? Precast? Yeah, we got precast and tilt-up. Okay, yeah, okay. Lots of street cred for somebody who knows the difference between precast and tilt-up.
I have no issue.
Anybody know the difference between precast and tilt-up?
One is done on site and the other.
Yeah, bang on. Wow. Look. Yeah, you'll be able to walk around here like for weeks.
Makes sense. Yeah, you do it before.
Yeah. So precast, that happens in a factory. Yeah.
It makes sense though.
Yeah. So that all happens in big casting beds inside a factory, and your tilt-up, that happens on site. So typically you'll pour your concrete slab. Let's say we're doing a tilt-up warehouse. You pour a concrete slab, and then once that's all gone off, put plastic down, do formwork on that, and pour slabs of concrete separated by plastic on top of each other. Obviously, you're pouring, your process of pouring, your staging of that. You'll pour the first slab you want to tilt up is the last one you pour, because it'll be latest on the stack. So you've got to get that ordering correct. So that's your tilt up. You pour it all on that slab on site, whereas your precast, that happens in a factory elsewhere, and they'll get cast and then craned and sit around the yard or so until they're required. Tilt up can be quite a bit cheaper than precast. So precast, you're paying for that factory and any errors and all that sort of stuff. You're looking at around $15,000 or so for a panel. But at $300 a cubic metre for concrete, you can do panels yourself much cheaper on site if you want to go through that process. But it all depends on how much space you have on site. Sometimes you don't have space. Sometimes you don't have time. Either way, whether it's tilt-up or precast, the propping is incredibly important, because so you'll notice on this job there's a huge amount of propping there. That's because if a concrete panel were to tip over, it's disastrous, incredibly dangerous, and all of that has to be propped in place accurately until all the panels go in and lock each other together. So that's within a precast factory working on the casting beds. So you can get a much more reliable uniform product out of precast than a tilt-up. Limitation for either of these, tilt-up or precast, is the transportability and the placing on site. So there are going to be limitations on the size of panel you can do. Also, I had a job repairing it was like a supermarket thing at a place called Freegon, which is in the AP Wildlands up near Alice Springs. So still, I think it's about 300 or 400 k's from Alice Springs still. So one precast panel got damaged in a fire, and it was about replacing one precast panel. The reinstatement for that is quite a difficult process, because you've got a precast panel back here, goes up to Alice Springs, gets taken out to the site, and you need a crane taken out for one panel. So in some situations it can be so economically very unviable for doing. But then in other situations where you're doing a lot of panels, you've got that crane on site. There's the economies of scale in that. But you've got to think about the weight of those panels, how they can be lifted into place, whether you've got a crane adequate for lifting them, what that crane is going to cost, and whether those panels can be transported to site. Precast used both for commercial and for residential, typically not used for single residential because it's hard to incorporate insulation into them. You can batten out a wall and include insulation in it, but when you get to multi-residential type construction, then the requirements for energy efficiency and insulation differ, and so you could be using products more like precast or tilt-up. Makes fantastic fire separation walls. So we talked about different classifications of buildings really early on in the piece. Well, actually with any building, with any type of building, whether it's class 1, 2 or 3, you need to have fire separation between those buildings to allow separate title to happen. So concrete panel walling creates excellent fire separation. It's not the only way, but it creates a continuous form of fire separation. You'll notice on the end of these panels here, you've got these dark patches there. That's from the lifting lugs. So in all of your precast panels, you have little metal lugs cast in there that the crane slings attach onto. So they've just got this hook, and it hooks around those lifting lugs and lifts them into place. But because you don't want to see those lifting lugs once the building's built, you concrete over them. But that's a really good example of showing how difficult it is actually to match concrete colour from your concrete mixed up on site and your concrete from the concrete panel. And so that's a drawback of precast or tilt-up, is that any damage that gets repaired stands out. What we don't have in the slides there are any typical details for tilt-up. What you want to have happening with your precast or tilt-up buildings is all of those pieces locking in together and supporting each other. That's typically done by what are called cast-in ferrules. So cast-in ferrules are basically like little top hat shaped nuts. So threaded pieces that get cast into that concrete that enable you to screw a bolt into that cast-in ferrule. That with all those cast-in bits, or those cast-in ferrules, that allows you to fix steel angles, etc., to lock all those panels in place together. Another really at the base of those precast walls, and I apologise for people at home that can't see this, is you'll have a slab, and then you'll have your steel dowels cast into the slab like that. There's your piece of steel like that. Can you guys over there see that? Usually, or it's a bit tight angle for you, Austin. Yeah. But you've got your steel rods cast into your concrete slab there like that, and then your tilt-up panel gets lifted on top, and it has an accommodation to sit around that bar, and a little tiny tube into that you pump non-shrink grout, fills up that whole bit, and locks that panel into place on the slab. So that's a really neat fixing detail for your tilt-up panel and floor slab junction. A less neat way of doing it is to have a steel angle in here. You fix there and you fix there. Much simpler and much easier to reinstate, but means if it's a warehouse, you don't want to have forklifts and things like that operating near that. You don't really want that sort of thing in a residence either. So that's the quick, easy, cheap way of doing it. That's your very neat way of doing it. Then typically at the top of your panel, you just use that steel angle there because you want something for fixing your roof too, and that makes a really nice, easy place for fixing any horizontal members too. But then at that point, it's not visible, people aren't kicking it, forklifts aren't running into it, etc. And so for where you're fixing your steel angle, that's where you have your cast-in ferrule, like that. That has the thread in that all your bolts get screwed into. Does that make sense for people? Yeah, some slightly quizzical looks about that. Um, yeah. You might, yeah. Look, if you work for an engineering firm, also you might have a bit to do with your detailing around that, or Bianco precast, or tilt up SA or something like that. You'll have a lot to do with those detailings. But yeah, but for your standard sort of building design practice, you're not dealing with those details all too much. So a system that's pioneered by architect Le Corbusier was about opening up buildings and allowing space through. That was done by columns and slabs. Well, you architects probably tell me a bit more about Le Corbusier. Than, yeah, yeah. I didn't study architecture myself, but yeah, it was sort of a revolution in building to move away from walls and enable large open spaces by the introduction of columns and elements that span between columns. And that's what we see in this, that's essentially what we see in this building here. Yeah, concrete used extensively in high-rise construction because it can be pumped into place and formed into place. Typically your lift shaft leads that construction. So that's, what was that? That's building in Melbourne. Does anybody know that building in Melbourne?
The Rialto?
Is that what it's called?
Yeah, I think
Rialto?
so, yeah. It looks like it.
Yep. No, that'd be the one. I don't know Melbourne all that well. Yeah, good night. Yeah,
Yeah, it looks like it. And then they had that. Yeah, no. And then they had the little yellow thing on the side.
Yes.
The sky deck that comes.
Yeah. So typically, when you're building a high rise like this, the lift shaft will go first. So that's cast in concrete, and then the rest of the building sort of gets built around that. Yeah, all sorts of things you can do with concrete. It can be formed into almost any shape. Basically, the limitations are on your formwork and how much you want to spend on your formwork. Oh, that's our boom pump there. So that's placing the concrete with the boom pump. And that's the screed in behind there. So the concreters would be pump operator would be placing the concrete around here, and your concreters will be moving the concrete around with the screeds. Troweling, so it's a helicopter trowel to finish off. Where area sit downs, we've seen those. Yeah, look, yeah, it's important that the concrete is stored adequately, and also that you have observe reasonable safety measures as well. You don't want to get cement powder in your eyes, and also dries out your skin a lot as well. Also, for major projects, your concrete companies will want to keep some samples for testing as well. Those samples are taken in these little forms, so they're all of a uniform size, and then all the samples are rotted to ensure that there's no air bubbles in there, and they're all uniform, dated and marked, and then placed in a curing bath. So that's probably the best way to go curing your concrete is in a temperature controlled body of water. That helps. That slows that reaction down as much as possible. So tests are taken on that concrete to ensure that that your concrete suppliers are providing the right product. And if there was any legal recourse at some point in time because the building failed for some reason or concrete didn't behave the way they wanted it to, if they have those samples there, those samples can be tested. I think that's Look, it's all about concrete testing and sampling. I think we can skip through that. Also, with the desire for people to have polished concrete in certain situations, then your mixes and your aggregates are super important. But I think the flavour of the day is moving a little bit away from polished concrete these days in favour of things like burnished concrete and your steel trowel finishes, etc., where your aggregate's not so important. But your various different concrete companies will produce different colours, different mixes by adding by adding oxides to them to darken up a mix or lighten up a mix, and then your various different coloured aggregates. So that's a bit of concrete which has been cut away. But also you can have exposed aggregate like this for driveways and paths, etc. That's done by after it's been troweled off. You spray it with a mixture of water and sugar, and then you've done that.
Yeah.
Yeah.
Yeah. Well, it's you just buy it. I forgot what they call it, but yeah, it's just water and sugar almost. And
Yeah.
then leave it for a bit.
Yeah.
And then just spray it off with high pressure hose.
Yep. Yep. Exactly.
Or
So.
you can, it depends how good you are. You can just spray it off with a normal hose.
Yeah. If you get enough pressure on it. Yep. Yep. Yeah, so that water sugar mix that just softens the concrete. It makes the concrete not set properly on the top, and you wash away the slurry out of that to create that pebble dashed finish. Another thing, have you done sprinkling salt on concrete? Yeah, rock salt. So that's another way of getting grip into concrete is you sprinkle rock salt onto the top of it after it's finished. And then once it's all hardened and cured properly, you wash that away as well, and the salt obviously washes away and creates little cavities in there. So what do you call it? Call it salt. Yeah, I don't know. I can't remember what the finish is called. But yeah, basically you sprinkle rock salt on there. And that's Oh, okay. Well, yeah. In terms of hazards, so typically concrete used appropriately is not particularly hazardous, but you want to avoid getting cement powder in your eyes. It does cause a fair bit of irritation to open cuts and wounds and so on, and also concrete as it's going off produces a lot of heat, or can produce a fair bit of heat. So you have to be careful with that. Also, you've got to be careful of concreting in hot weather inside sheds as well, because it can get really hot. I don't know if you've done any of that, but yeah, you've got to keep the fluids up. Yeah, I'll leave out the hand signals for your research at home. So, any questions or so in regards to that, or comments, etc. All right.